Lesson 6-6, Parallel and Perpendicular Lines. In this lesson, you learn to determine if two lines are parallel or perpendicular by their slopes and to write equations of lines that pass through a given point, parallel or perpendicular to the graph of a given equation. Why is it important? Because you can use a parallel and perpendicular lines to solve problems involving health and construction. Let's take a look at this real-world application on world cultures. Kite making has been a national sport in some Far East countries since ancient times. In September, Chinese families celebrate the uh, ninth moon as kite kites day. Okay, so entire families go outside and fly kites. These kites may be simple diamond shaped or more complex shaped like fish, birds, dragons, and colorfully dressed people. Okay, so when you talk about a kite, okay, the outline of a simple kite is shown on the coordinate plane at the right, which is this one. Okay, the ordered pairs for the tips of the kites are labeled. Okay, we know that the two slats that support the kite meet at right angles. Okay, lines that intersect at right angles are called perpendicular lines. Okay, you will learn more about these later in the lesson. So this is a kite, and you know that uh, these two lines right here, the two pink lines, are perpendicular lines because they form right angles. Okay, and we're going to talk about that later. Okay, when uh, uh, when you talk about lines in the same plane that never intersect are called parallel lines. Okay, are called parallel lines. Parallel lines can form families of graphs. In lesson 6-5a, you learned that families of graphs can either have the same slope or the same intercept. The graph at the right shows a family of graphs. Intercept are represented by the following equations. Y equals 2x plus 3. That's the pink line. The blue line is y equals 2x, and the green line is y equals 2x minus 1. Okay? So these are your equations. Y equals 2x plus 3, y equals 2x, okay, and y equals 2x minus 1. So the parent graph is y equals 2x, okay? Now, why is it called the parent graph? Okay, because if you notice very carefully, they are all parallel lines, okay? And if you follow if you remember the slope-intercept form, wherein the slope-intercept form goes y equals mx plus b. Okay, m is our slope, okay, and b is our y-intercept. So in all these three lines, what do you notice? That the slopes are all the same. Okay, so their slopes are all equal. The slope for each line is 2. Notice that the lines seem to be parallel. In fact, they are actually parallel to each other. So what do you notice about parallel lines? Parallel lines will have the same slope, but not necessarily the same y-intercept. Okay? So let's define parallel lines in a coordinate plane. If two non-vertical lines have the same slope, they are parallel. All vertical lines are parallel to each other. That is a given. So if you have two parallel lines, since vertical lines have undefined slopes, okay, they're still considered to be parallel to each other if two lines are defined to be vertical. Okay, so a parallelogram, by definition, is a quadrilateral in which opposite sides are parallel. We can use slope to determine if quadrilaterals graphed on the coordinate plane are parallelograms. The slope of a segment is the same as the slope of a line containing the segment. Okay, So let's look at example 1 and see how this one works. Determine whether quadrilateral ABC is a parallelogram if its vertices are A, negative 5, 3, B, 5, 3, C, 7, 9, and D, negative 3 and 3. First, we need to graph the four vertices and connect the vertices to form a parallelogram, such as this one. So vertex A, vertex B, C, and D. Okay, and we plan to use each pair of vertices to find the slope of each line segment, meaning we're going to use point D and point C to find the slope of DC. We're going to use A and B to find the slope of AB. Okay, to find out if they're really parallel to each other, we want to find the slope of AD and the slope of CB. Find out if they're parallel. If they're parallel, then that means they are. It is a parallelogram. So we will use the equation m equals y2 minus y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So let's find the slope of segment AB right here. So it's going to be 3 minus negative 3 and 5 minus negative 5, okay, because you're using point A and point B. Okay, so if you use those, you end up with a slope of 3/5. So the slope, okay, of segment AB will be 3 over 5. Let's find out the slope for segment BC. Okay, so segment BC, again, using points B and point B and point C. We have 9 minus 3 all over 7 minus 5. The slope for BC is 5. And point CD, okay, again using point C and point D, okay, we have a slope of 3/5. And if you notice right there, AB and CD are already parallel to each other. Okay, so one more time, if AD is parallel to BC, then we have a parallelogram. And as it appears, okay, using point A and point D, we have a slope 3. So BC are also parallel. Okay, so segment AB and segment CD have the same slope 3/5. BC and AD have the same slope 3. Both pairs of opposite sides are parallel. Thus, ABCD is a parallelogram. Okay, so to check our answer, another definition of a parallelogram is that its opposite sides are congruent or equal in length. So we use a ruler to measure segment AB and segment CD, and they're approximately 37 millimeters long. BC and AD are approximately 20 millimeters long. So the figure is probably a parallelogram. Okay, let's take a look at example 2. You can write the equation of a line parallel to another line if you know a point on the line and the equation on the other line. Okay, so basically what it's saying is this: if you want to write an equation in slope-intercept form, remember slope-intercept form, y equals mx plus b, of the line that passes through 4, 0 and is parallel to the graph 4x minus 3y equals 2. So we want to find an equation of a line, okay, where you only have one point and you're given another line that is parallel to that line. Okay, so what do? We put it in, or we want to find the slope by rewriting the equation in slope-intercept form. We can actually find the slope right away by using the formula. Okay, m is equal to negative a over b, finding the slope for standard form, because we know that this is in standard form, and we know that a is 4, okay, and b is negative 3, so it's negative 4 over negative 3, so the slope would be, okay, 4/3. Okay, but solving for y, this is how we do it. First, copy the equation, 4x minus 3y minus equals 2, and then subtract 4x to both sides. Negative 3y equals negative 4x plus 2, and then divide both sides by 3. Okay, y equals 4/3 x minus 2/3. And if you notice, we have the same slope, 4 over 3. So our slope is 4 over 3. Okay, let's use method 1 to find the equation. In method 1, we are going to use the point slope form. So again, this is the point slope form, and we want to substitute this point right here to x and y, 4 and 0. So we substitute x and y to 4 and 0, we end up with y minus 0 equals 4/3 x minus 4. Okay? And then we simply solve for y. Y equals 4/3 x, 4/3 x minus 16 thirds. And we want to, we know that this is in slope-intercept form, okay, already. So an equation would be, for this line is y equals 4/3 x minus 16 over 3. In method 2, instead of using the point slope form, we use the slope-intercept form, y equals mx plus b. So what do? Again, we substitute the point that it passes through, which is 4, 0, and substitute it to our equation, slope-intercept form, and our slope. So we have now y equals, 0 equals 4/3 times 4. 4/3 is our slope plus b, and we can solve for b. So b is equal to negative 16 over 3. And what do we do with that? We simply substitute the values for m and b into slope-intercept form. And we know that our slope is 4/3, and we know that our b is negative 16 over 3. So it's y equals 4/3 x minus 16 over 3. Okay? Let's take a look at example number 3. Sometimes graphs can be drawn in a way that leads you to wrong conclusion. Mathematics can help you determine if a graph is misleading. Let's take a look at this one. The American Heart Association recommends that men keep their weight within a certain healthy weight band. Okay, as shown in the graph at the right. Are the lines parallel as they appear in the graph? So this is your healthy weight band. That means your height and weight should fall within that band for you to be considered healthy. Okay, so from the graph, we can determine that the endpoints of the minimum edge are 94 and 58. Okay, and 148 and 74. So this is 94.58, and this is 148.74. The endpoints of the maximum edge are 110 and 58. Okay, 110 and 58. 110 and 58, right around there you go. Okay, and 175 and 110.58, 110, 175. The other one is 94.58 and 148.74. Oh, okay, that's the one. Those 4 points right there. Okay? So we want to find if they're parallel or not. So let's use the slope formula. Okay, so the slope of the top line, which is 148 and 74 and 94 and 58, okay, will be about 0.30 using our slope formula. And the slope for our bottom line, okay, will be about 0.25. Okay, if you notice, their slopes are not the same. What does that mean? That simply means that they do not have the same slope, therefore they are not parallel as they appear in this graph. So if you notice, they look parallel, but if you apply what we know about parallel lines having the same slope, they have two different slopes, therefore those two lines are not parallel. Okay, let's take a look at example number 3, or number 4, that is. Refer to the application at the beginning of the lesson. We have seen that the slopes of parallel lines are equal. What is the relationship of the slopes of perpendicular lines? Remember, we talked about the kite. Okay, and if we go back to the picture of the kite, this is how it looks like right here. Okay, There you go. Okay. And you know what? I'll copy this. Okay, copy, and I will place it where our problem is on example 4. So right here. Oopsie. Oh, that didn't work. Okay. Let's try that again. Okay. Up here. There you go. I'm going to get that. I'm going to copy that to our problem, so we won't have to go back and forth. There you go. We'll make it smaller. Okay. Put it here. Okay, so write the equations of the lines containing the slats of a kite in slope-intercept form. Determine the relationship between the slopes of perpendicular lines. Okay, so the long slat, okay, which is that one, we want to find that slope. And we're using the origin and 8, 4 as our points. We find our slope to be 1/2. Okay, representing x sub 1 and y sub 1 as 0, 0. And if we use the origin and use the point slope form to find the equation of a line, then we can determine that y equals 1/2 x. So knowing that y equals 1/2 x tells us that the slope is equal to 1/2. On the short slat, which is this one, we use the points 5, 5, and 7, 1. Again, we want to find the slope by using the slope formula. We end up with a slope of -2. Okay, and then we use 5, 5 as our x sub 1, y sub 1 for our slope-intercept form. And then we end up with y minus 5 equals -2 times x minus 5. So our slope, okay, will be, after the distributive property, -2x plus 10. And then we simply add 5 to both sides to get the y slope-intercept form, end up with -2x plus 15. And our slope in this case will be -2. So equations of the slats are y equals 1/2 x and y equals -2x plus 15. Okay, so what do you notice? The slats of the kite are perpendicular. The slopes of the slats are 1/2 and -2. The two slopes are negative reciprocals of each other. Note that their product, 1/2 times -2 or -1. Okay, if you're already confused with that statement, okay, when you talk about reciprocals, a reciprocal of a number is that they have a over b times b over a is equal to 1. So their product is equal to 1. So when you say negative reciprocals, instead of 1, it becomes -1. Okay, -1. So that's a negative reciprocal. So what happens here is that if you get 1/2, what will you multiply 1/2 with to give you the value of -1? In this case, the value would be -2. X would be -2 to give you the value of -1. So therefore, -2 and 1/2 are called negative reciprocals of each other. And that's how it goes in terms of perpendicular lines. Perpendicular lines, okay, have slopes that are negative reciprocals of each other. Okay, and this is what we know right now. This is just this. Okay, if the product of the slopes of the two lines is -1, then the lines are perpendicular. In a plane, vertical lines and horizontal lines are perpendicular. Okay, the slopes of perpendicular lines are negative reciprocals of each other. So let's take a look at example number 5. Okay, you can use your knowledge of perpendicular lines to write equations of lines perpendicular to a given line, just like what we did in example number 2. Okay, so in this one, write the slope-intercept form of an equation of a line that passes through 8, -2 and is perpendicular to the graph of 5x minus 3y equals 7. Okay, so again, let's visualize what we want to happen here. you have we want or they want you to find the slope-intercept form of an equation of a line. So the slope-intercept form is y equals mx plus b. Okay, that form. And that line should pass through the point 8, negative 2, and is perpendicular to the graph of 5x minus 3y plus 7. Okay, so we have a line that is 5x minus 3y equals 7. Okay, and there's a line that passes through it, and it should be perpendicular. What is that line? That is perpendicular to this line and passes through the point 8, negative 2. Okay, so first things first, let's find the slope of the given line. Okay, again, finding the slope of the given line, we have 5x minus 3y equals 7. We are solving for y to make it y equals mx plus b, so we can find the slope. Okay, which is y equals 5/3 x minus 3 after solving for y. So the slope is 5/3. If you recall, we can also find the slope by using m equals negative a over b if our equation is in standard form. In this case, it is, because it is ax plus by equals c. So our a in this case would be 5, and our b in this case would be negative 3. Okay, since if we apply this formula, m equals negative a over b, it's going to be negative 5 over negative 3, or simply 5/3. So that's another way of finding the slope of this particular line. Okay, now that we've found the slope, okay, the slope of a line is 5/3. Remember, if they are perpendicular, the slope of a line perpendicular to this line is the negative reciprocal of 5/3, or negative 3/5. So after finding 5/3, we want to find the negative reciprocal of 5/3, which is negative 3/5. So that means that line that will pass through 5x minus 3y equals 7 and passes through 8 negative 2 should have a slope of negative 3/5. Again, we go back to our point slope form to find the equation. y minus y sub 1 equals m times x minus x sub 1. Okay, and we use the point, okay, 8 negative 2, okay, for our point slope form, and use the negative reciprocal of negative 3/5 for our slope. Okay, so you now have y minus negative 2 equals negative 3/5 and x minus 8, using 8 negative 2 as x sub 1 and y sub 1. Okay, simplifying it further, you have y plus 2 equals negative 3/5 x plus 24/5 using the distributive property. Okay, and then subtracting 2 to both sides. Okay, you have now negative 3/5 x plus 14/5. Subtract 2, or 10/5. Why 10/5? Because it's easier to subtract 10/5 to 14/5. Okay, and 10/5 is 2 as well. Okay, and if you notice, we are now in our slope-intercept form. So the equation of a line is y equals negative 3/5 x plus 14/5. That is the equation of a line that will pass through 5x minus 3y plus 7. Okay, and sorry, not pass through, but perpendicular to the line 5x minus 3y equals 7, and will pass through the point 8, negative 2. So if you want to visualize what we are trying to find out, let's say this is let's say this is 5x, okay, minus 3y equals 7. Okay, the line that will pass through it, okay, let me make it straight this time. The line that will pass through it, something like this. Okay, and let's put arrowheads on it. Okay, and is perpendicular to it and will pass 8 negative 2. Okay, let's say this is 8 negative 2, will be negative y equals negative 3/5 x. plus 14 over 5. Okay, so basically in the beginning you are given this line right here. Okay, and you are also given a point. So we want to find the line that is perpendicular to 5x minus 3y and passes through the point 8, negative 2. Okay? And that's the end of our lesson. Thank you for watching. Oh, before you go, the secret word for this lesson would be Stanford. Again, the secret word for this lesson is Stanford. Thank you.